Other questions?
Yeah, I have a question. On problem set 5, how would you start number 2? Would you put it in like vector form and then do cross? What's it called? Cross product?
So first of all, you need to find the normal vector of these two, right? Did you do that?
Mm-mm.
Normal vector of these two planes? I mean, sorry. So you're talking about 2, right?
Yeah, 2.
The line intersects the plane. Okay. So to do that, you need to use the, so this is plane and this is line. So you need to know this point, right?
Got it.
So to do that, you need to write the parametric equation of that. So first I will write the symmetric way. This is not symmetric form, by the way. You need to divide by 2, right? Because remember the symmetric form, x minus x naught over a, y minus y naught over b, z minus z naught over c, right? So all xyz are just by themselves, but this is 2z. So you need to divide by 2. If you compare that, it would be x over 2, y minus over y over 2, z over 2, z over 1, right? So you clearly can see this line goes to the point 0, 1, 0, and the direction vector is 2, 2, 1, right? Now if you equate all this to t, then you get your parametric equation. So x would be what? 2t, y would be 1 plus 2t, and z would be 0 plus 1t, right? Is this clear how we get the parametric equation?
Mm-hmm. Yeah.
Okay, so what does that mean? That means for each value of t, this gives you a point on the line. So that means, in particular, this point is also has this form 2t, 1 plus 2t, and t for some value of t, right? So you need to find that value of t, then you're done. So what else can you use? What other information can you use? How can you find this value of t? This point also lies in the plane, right? So if you plug this thing in the equation, this will satisfy this, right? So that means 4 times 2t minus 1 plus 2t, and 3 times t must be 8. Then you can find the value of t. It's similar to the problem 6.
I have a question about problem 4 on problem set 5. If I could ask that. I understand that taking both normal vectors and doing the cross product, normal vectors coming off the plane, cross product gives you your direction vector of the line. But how do we find a particular point to which that line segment should be referenced off of?
So you have two planes, right? One is
Right.
this, and another is maybe something like that. So that means what? You want to find a point in the intersection here. So that any point in here will satisfy this equation and also this equation, right? Both of them. You can just choose something, right? For example, let's say, I mean, there are infinitely many ways to do that because there are infinitely many points, right? So plug, for simplicity, plug z equals 0. Okay. So your answer may not be same as my answer, but is equivalent. So if you plug z equals 0, then you know the point you're looking at that will look like this, right? So now if you plug z equals 0, then what you'll get equation? X plus y equals 1, x plus 2y equals 1. Okay. So now you can solve for x and y. For example, if you subtract, you get negative y equals 0, right? Y equals 0. Then x equals would be what? X equal would be 1. So 1, 0, 0 is a point, isn't it? Plug x equals 1, 0, y equals 0, z equals 0. That satisfies this. This also satisfies this. That means what? Any point that satisfies both equations, that is a point on the intersection.
Got it. Thank you.
Other questions? We have 10 minutes.
Could we go over 1C really quick from problem set 5?
One C, what does that say? A plane through the point and perpendicular to the planes, both planes. So what will be the rough picture? You need to draw two planes and you need to find a plane that is perpendicular to both, right? So one hard to draw. Is not necessarily parallel, but I'm just trying for now. And then your plane like this, right? So what is the direction vector or the normal vector of the first plane? 2, 1, -2, right? So I'm drawing like here. 2, 1, -2. That means our normal vector lies on this plane, what you want to find, right? And let's see another. And the normal vector of the second plane is what? 1, 0, 3, right? That is also like something like this. That is 1, 0, 3. So that normal vector is also lies in the plane you want to find. Okay. So now think about it. You want to find a plane. You know two vectors on the plane. How do you find the normal vector to the plane?
Do we have to find the cross product between them?
Yeah, exactly. So now this normal vector would be the cross product of the normal vector of these two planes. So the normal vector you want to find is going to be 2, 1, -2 cross 1, 0, 3. And then you have the point.
Gotcha. Perfect. Thank you.
Yeah, so do you see that the rest is algebra, but the
Yeah.
fundamental idea is how you get to this point.
Gotcha.
That's why the rough sketch is really needed. You cannot do the plug and chug and mechanical way.
Yeah. Awesome. Thank you.
Yeah, 5 minutes. Other questions? Is anybody having trouble with the problem 4 in wave work? Is anybody got it correct? Problem 4 in the plane wave work.
I got it right, but I don't remember quite what I did to do it. You said number 4?
No, I'm asking for a reason. Seems like there might be a bug in wave work.
I got it right. It's because you have to make it positive when finding the magnitude, right? Or
Yeah.
Yeah.
You had to take like the absolute value of it,
yeah.
which was where I kept messing up on it.
Are you guys in the same room?
No, I'm in the same room as Lindsay.
Uh, angle between planes. It's supposed to be easy problem. You just find the angle between the normal vectors. Other questions? We still have 4 minutes, 3 minutes. No? No more questions? Okay then, read about 13.1, which is vector valued function. So the idea is you already have f of x equals x squared plus 1. But now vector valued means you're applying actually is function of t, and then you get a vector, some form of vector. Not good. Maybe 2t minus 1 minus t squared. So the output is a vector. That's called vector value. It represents a curve in 2-dimensional or 3-dimensional space. So read about it, and we'll discuss tomorrow. All right, guys. I'll see you tomorrow.
Professor,
Yes.
I missed your meeting for today. I was a little bit busy. Could I take 5 minutes of your time?
I cannot give you time. You need to come to my office hours. I have another class right now.
Oh, could I send an email and see, figure out when is the free time for yours?
You should be able to know what is the office hours.
No, I told you I missed it out because I was busy. So
You cannot come to office hours?
no, because I'm working in a project, so it's a little bit messy. I can meet other persons, and that conflict with yours.
Yeah, you can come tomorrow. I have office hours tomorrow.
Wait, come to you in person?
Not in person, over Zoom.
Oh, okay. We'll do double check. Thanks.
Yeah.